Hi dear students, okay, so welcome to today's Brainiacs Capsule, okay. So we are today discussing an important chapter that is from physical chemistry, that is atomic structure, okay. So this chapter fundamentally focuses on atoms and its basic terms, and it's a very important chapter to understand the fundamentals. So I have chosen 3 important questions from this particular chapter, okay. We will take one by one, and if you have any doubt, feel free to put as a comment on the comment box. Okay, yeah, starting with the first question, all of you, please answer, try to answer along with me. So, which of the following statements is not correct? So, they have given you 4 statements and you need to identify which among that is not a correct statement. So, the first one is the shape of an atomic orbital. Okay, it depends on azimuthal quantum number. Okay, the second one, the orientation of an atomic orbital is given by magnetic quantum number. And the third one, the energy of an electron in an atomic orbital of a multi-electron atom. It depends on the principal quantum number only. And the fourth one, the number of degenerate atomic orbitals of one type depends on the values of azimuthal and magnetic quantum number. Okay, so if you want to answer this question, you should have a rough idea on quantum mechanics. Okay, I hope you have a fair idea. I will give a brief summary of what it is and then we will go to the answer very fastly. Okay, so coming to the quantum mechanics, so fundamentally quantum mechanics, it helps you to describe an atom, or if you want to specify especially regarding where an electron is situated in an atom. In quantum mechanics we need 4 identification numbers. So the first one that is required here is a principal quantum number, second one is azimuthal quantum number, third one magnetic quantum number, and the fourth one spin quantum number. So each of these identification numbers or the quantum number give you an idea exactly where this electron can be located fundamentally. Okay, so the first quantum number, that is the principal quantum number, it was given by Bohr. You know the scientist Bohr. Okay, so what does it represent? It gives the energy of the shell. Okay, so it represents fundamentally the shell or the orbit, you can say, to which that particular electron belongs, because we believe that there is a central nucleus and surrounding the nucleus we have different shells are there, and these shells or orbits are called KLMNO orbits or KLMNO shells. Okay, and we can say that if n or the principal quantum number is equal to 1, n is equal to 1, then that indicates it is a K shell. If n is equal to 2, I can say the corresponding orbit is L, or I can say it's a second orbit. And if principal quantum number is equal to 3, I can say it is an M shell or it is a third orbit, like that. Okay, so I can say that it's a third orbit means you have the first orbit here, second orbit here, and third orbit here. So it is moving farther from the nucleus. So I can say that greater the value of n, greater will be the distance from the nucleus. Okay, so you can see here the radius r is, now you can say that it is inversely proportional to the atomic number z and directly proportional to n square. It's correct only, right? Because if the n value is increasing, the orbital number is increasing and its distance or the radius from the central nucleus is also increasing. So that's why we have a relation like that. So if you are taking different atoms, you need to appropriately substitute for different values, that is values of Z, because different atoms have different atomic number. For example, hydrogen atom, the atomic number would be 1. Helium, the atomic number Z would be 2. Like that it would keep on changing. So if we are analyzing, we can easily say that the radius 5 would be much bigger than radius 4. No doubt, because radius 5 means n value would be 5. Very simple. Okay. Yeah, that's it about the radius. Now, I also told that the n will give you the idea of energy also. So, energy is what actually? Energy of a particular shell or orbit is given as minus 13.6 into z square by n square. So, you can see here energy is actually inversely proportional to 1 by n square. Actually, radius is directly proportional to n square. So these are inversely related. That means if you move farther away and you can say that here it is negative, actually negative value, don't forget that, and that's very very important. Okay, so that means if it was positive, I can say as you move farther away from the nucleus, energy decreases, but it's totally different. If you move farther away to the nucleus, the energy increases. Why? Because it is negative value here. So that is the reason why E4 is greater than E3, which is greater than E2, and which is greater than E1. Or if you still have a doubt, put we will take Z as a constant, maybe 1, and we will put different values of E. We can understand that, then it will become clear for you. For example, when I am putting N is equal to 1, so you will get minus 13.6 atomic hydrogen atom I am taking, so 1 by 1, so minus 13.6 is the energy. Now when I am taking second orbit, so I can say minus 13.6 into 1 by second orbit means 2 square, it is 4. So 13.6 by 4 is approximately how much, sir? I can say minus 4 into 3, 12, 1, 3.4. So you can say which one is a higher value, minus 13.6 or minus 3.4. Please consider the negative, that's what I am saying. So this would be greater. So that's the reason why I told this is E1 and this is E2. And this trend is going to follow. Next E3 will come and thereafter E4 will come. I hope you are understanding. Okay, this understanding is very very important. Okay, so most of the students used to make a mistake at this point. Okay, the next concept here is with respect to velocity. We also get velocity from principal quantum number, and it is given by the equation V is equal to 2.18 into 10 power 6 Z by N. So we can say here also velocity is inversely proportional to principal quantum number N. That means if you move farther away from the nucleus, the velocity of the electron, it keeps on decreasing. So that's the reason why velocity in the first orbit is very high, then followed by second orbit, then followed by third orbit. Now the angular momentum of this particular, we know that any object which is revolving around any axis will have an angular momentum. So angular momentum of this electron in this particular orbit which is rotating is given by mvr is equal to nh by 2 pi. Very very important. Okay, mvr is equal to nh by 2 pi. So mass of the electron, velocity with which it moves, radius, n is the we can say principal quantum number, and h by 2 pi. Okay, and we can also calculate the number of electrons in a particular shell using this particular formula 2n square. For example, in the first shell, K shell, so what is the number of electrons, sir? I can easily say 2 into 1 square. So that will be 2 electrons can be accommodated in which shell, sir? I can easily say in the K shell. Okay, now similarly if you take L shell, how many electrons? So I can say 2 into 2 square. Okay, that is 4 into 2, 8 electrons. So I can say 8 electrons can be accommodated in the L shell. Now if you go to M shell, so 2 into 3 square. Okay, so that means 18 electrons can come in M shell. Clear? And going to the N, 2 into 4 square. So 16 into 2, 32 electrons. So you can easily say 32 electrons will come in the N shell. Clear? So it's very simple fundamentals you need to remember. That's it. Okay. Now coming to the next quantum number, next identification number, it is called azimuthal quantum number, angular quantum number, secondary quantum number, or even subsidiary quantum number, and it is represented by the letter small l. Very very important. Okay, and it's given by Sommerfeld. Okay, so what does it represent? That is most important. It represents the subshell. That means electrons are revolving in an orbit, and inside the orbit there is something called a subshell is present. Inside that subshell the electrons are present. So we need to know what is these subshells, what are they, what are the different types of subshells it is present there. All those things are given by the values of L. So what are the possible values of L's are very very important. So L value starts from 0, 1, 2, 3, 4, it goes like that up to n minus 1. So that means if you know the value of n, for example the n value is 2, I can easily say the possible L values. N value 2 means I know KL. So it is L orbit they are speaking about. In that particular second orbit, the possible values of subshell are, I can say 0 to n minus 1. That is how much? 0 to n value is 2. So 2 minus 1. So I can say 0 to 0 to 2 minus 1 is 1. So I can say 0 and 1 are the possible L values. So if it is 0 means that means there is a S subshell. If it is 1 means there is a P subshell is present. So I can easily say if you go to the orbit L, it can have two types of subshells, that is S and P. It's a simple understanding. Clear? So the same thing I am explaining here. So if the N value is 1, you can see L can have only one value, that is 0. That means it should be an S orbital. If N value is 2, it can have two values, 0 and 1, and the values should be S and P. Correct? Why it is 2S and 2P? Because N is 2. That's why 2S and 2P. Here why it is 1S? Because N value is 1. Correct? Now think, if N value is equal to 3, what are the possible values? 0, 1, 2. 0 to N minus 1. So that means 0 means S, 1 means P, and D here 2 means D will come into picture. Correct? So since N value is 3, I can say 3S, 3P, 3D. Clear? And N is equal to 4. Similarly, I can say 0, 1, 2, 3. And it is when N is equal to 4, we can say 4S, 4P, 4D and 4F. That's it. Very simple to understand. Okay. So now, if you want to arrange this in the form of energy, I can easily say that if the value of N is same, there are two possibilities. If N value is same, then the order of energy of the various subshell will be like F subshell will have higher energy, then D, then P, then S. For example, if I am comparing fourth orbit, complete fourth orbit, I can easily say 4F has higher energy than 4D, which has higher energy than 4P, and which has higher energy than 4S. Hope you understood. Okay, now we will take the second case where L value is the same. That means we are comparing different S orbitals. Okay, in that case N value is different. Then I can say the order of energy will be the one with the higher N value. So 6S, then 5S, then 4S, 3S, 2S and 1S. Now similarly I am taking here also L value same, that is all are D orbitals. Then 6D will come first, then 5D, then 4D, then 3D. Very easy. Understood? Now coming to the next one, that is the magnetic quantum number. So it was given by Linde. This was given by Linde. And what does it represent, sir? That is what is very important. Now I understood that there is K shell, L shell, M shell, N shell, different shells are there. Inside that shell, there is subshells are there. Subshells can be S, P, D and F. Now, this magnetic quantum number is giving you the orientation of the electron cloud. It is going to talk about, suppose P subshell is there. In that P subshell, how the electron is going to orient. Suppose it is orienting along the x-axis. Then I can say that P subshell belongs to the category Px, because the electron is orienting in the x-axis. Suppose if it is orienting in the y-axis, then I can say it will be Py. And if it is orienting in the z-axis, I can say Pz, like that. Hope you understood. So it gives, fundamentally, the magnetic quantum number gives you the orientation of the electron cloud. Okay. So I can say under the influence of the magnetic field, each subshell is further subdivided into different small orbitals. For example, I have a P subshell. Now I can easily say this P subshell is further under the influence of magnetic field. It is divided into, or it is further divided into Px, Py and Pz. All this Px is called a single orbital, Py is called another single orbital, and Pz is called another orbital. So when electron is present in Px orbital, I can say its orientation is in the x direction. Clear? Very simple. Okay, hope you understood. Now what are the possible values of M? M is what this magnetic quantum number represents. So M can take values from minus L to plus L. So what does it mean? Students need a little clarity on that. Very simple, sir. Suppose I am starting with a principal quantum number N is equal to 2. Now you know that L can take the values what and all, 0 to N minus 1. So 0 and 1 it is possible. Now if you are taking M, if you want to find out M, first you need to take 0 individually. So what are the possible values of M? Minus L to 0 through plus L. So here L value is 0 means minus 0 and plus 0. It will be always 0. So I can say for the subshell 0 or S subshell, it can have only M value 0 is possible. Now L is equal to 1. L is equal to 1 means that is P orbital. Now for p orbital, I am taking the m value. M value would be how much? Minus 1, because it is minus L. So I am taking minus 1 through 0 to plus L. Plus L is what? Plus 1. So I am getting 3 values. So that means the p orbital is divided into px, then into py, and further into pz. Hope you understood the concept. Okay. Now some students may ask, sir, what happens if n is equal to 3, sir? Can you explain me? Very simple, sir. Listen, very simple. It's not complicated. It's very simple. Okay. Listen. Suppose n is equal to 3. In that case, tell me, sir, what are the possible values of L? I can say 0, 1, 2, because 0 to n minus 1. Now I know that when L is equal to 0, m value would be 0. That means S subshell. S shell, here it represents S subshell, and that will have only one orbital. There is no specific orientation. It will have only one orbital. Now when I am going to 1 means it is p orbital. So the p orbital can have m values what? Minus 1, 0 and plus 1. We have seen. So that means it have 3 orbitals, 3 separate orbitals possible. Correct? Like this. So what are its name? I can easily say this is px and this is py and this is pz. Correct? Now I am taking the next one. L value is equal to 2, spd. So that means its orbital is d, and the m can have values minus 2, minus 1, 0, plus 1 and plus 2. Now I can easily say this subshell D has 5 orbitals under that. So what are the orbitals? The minus 2. So I can say D orbitals are further divided into dxy, dyz, dxz. Then we have dx square minus y square. And finally we have dz square. But we need to map it correctly. Okay, these are the 5 different orbitals that is possible. Clear? So I am trying to explain you the idea behind this. Okay. I hope it is clear. Okay, any doubt? Yeah, let's move to the concept of orbital in detail for making you little more clarity I need to bring. Okay, so fundamentally what is an orbital? An orbital, I can say it's a 3D space around the nucleus where the probability of finding the electron is maximum. Okay, even though we say it's an orbital, inside the subshell there is an orbital is there, but we cannot exactly say at this point, or a coordinate I cannot mention, but we say this space, if you see, this area has the probability of finding the electron maximum. Clear? So fundamentally an orbital is represented by the function xi, okay, and it is represented by 3 values, or it can be analyzed with the 3 possible quantum numbers, that is n, l and m. It doesn't require spin quantum number. Please understand, it needs only 3 quantum numbers, n, l and m. That is highlighted here. Okay, I hope you understood. Now we see the different types of orbitals. This is for you to understand just. So we know that if L is equal to 0, we know that M is equal to 0. That means it is S subshell. We know that. So that means there are only one orbital, that is S orbital is possible. So different types of S orbitals are shown here. This is 1s orbital. Now when you have the 2s orbital, between the 1s and 2s you can see there are empty spaces present. That is called a node. When you draw 3s orbital, you have 1s here, 2s here, 3s here. So in between you can see what? In between you can see there are 2 vacant spaces. So there are 2 nodes, I can say. Nodes are places where the probability of finding the electron is minimum or no. Okay. Now the case 2. Case 2 means when L is equal to 1, you have a P subshell is present. So when P subshell is there, M can have values minus 1, 0, plus 1. So minus 1 Px, 0 means Pz and plus 1 means Py. Okay, and these are the different orientations. You can say when it is in a px subshell, px orbital, the electrons will be orienting like this, or it is present in this particular area. Okay, and when it is in py, I can say the electrons will be, the probability of finding the electron would be this area. In this particular area you can get the electron, or the probability is maximum. And if it is in a pz, I can say in this particular area the probability of finding the electron is maximum. Clear? Very simple. Now, when I am going to L is equal to 2, so you know that the 5 possible values are possible, that is minus 2, minus 1, 0, plus 1 and plus 2, and we know that D subshell is further divided into dxy, dyz, dz square, dzx and dx square minus y square. So please remember, whenever 0, m value is 0, it is dz square, minus 1 means dyz, minus 2 means dxy, and plus 1 means dzx, and plus 2 means dx square minus y square. Clear? So please look at the shapes. dxy means it is in the whole plane they are representing. Its xy represents the xy plane where the probability of finding the electron is maximum. dyz means it is a yz plane. So you can see the axis is z and this is y. So it is representing the yz plane where the probability of finding the electron is maximum. Next one is zx plane. You can see here. Okay, now the next one is x square minus y square. It's very important. Here you can see the orbital is located along the axis. This is axis and this is axis, and they can ask you one question: in which of the following d orbital have it is expanded along the axis, along the x and y axis? I can say dx square minus y square. And when this will come? This will come when the m value is plus 2. Okay. And the last one, dz square, is also very important, and it is also present along the axis, and this will come when m value is equal to 0. M value is equal to 0 means the corresponding this one would be dz square. Okay, I hope it is clear for you. Okay, now the last quantum number, that is a spin quantum number, it actually represents, or it says that the electron, when it is present in the orbital, it is also in the orbital itself, it is revolving around its own axis. Suppose this is a ball and it is revolving around its own axis. Okay, it is revolving around the nucleus like this. Okay, so this is the nucleus, means revolving around the nucleus. While it is revolving, it is also revolving in its own axis in this way, and it is coming like this, like moving along with the revolving like this. Okay, so here when electron is spinning in the clockwise direction like this, we represent it like plus or minus half. If it is in anti-clockwise direction, first we put minus followed by half, followed by plus. And since the electron is spinning in its own axis, we have another angular momentum coming, that is called spin angular momentum, which is nothing but root of s into s plus 1 h by 2 pi. And please understand how to represent the two electrons. Whenever the electron, we know that an orbital can hold maximum of 2 electrons. For example, px, or if it is py, whatever be it can hold a maximum of 2 electrons. So whenever 2 electrons are present, always one electron is spinning in the clockwise direction, means another one should spin in the anti-clockwise direction. So always it would be like this. Normally in an orbital, 2 electrons cannot have the same spin. That means 2 electrons cannot be clockwise simultaneously, nor it cannot be anti-clockwise simultaneously. Hope you understood the concept. Okay, now let's try to answer this question. It would be very easy for you. Yeah. Which of the following statements is not correct, sir? The shape of an atomic orbital. The shape of an atomic orbital depends upon the azimuthal quantum number. It's completely correct, because we know that azimuthal quantum number is L, and if L value is 0, it represents S orbital or S subshell. If it is 1, it represents P orbital and it is dumbbell shaped, and if it is a value is 2, then it is D orbital, and we know it's double dumbbell shaped. Correct. Next one, the orientation of an atomic orbital is given by magnetic quantum number. Exactly correct. Why? Because when it comes to magnetic quantum number, we know that if it is p orbital, it can orient in 3 ways, that is px, py and pz. If it is d orbital, it can orient in 5 ways, dxy, dyz, dxz, dx square minus y square and dz square. Correct. So fundamentally I can say that the orientation of the electron cloud is decided by our m value. M value is what? Magnetic quantum number. L represents what? Azimuthal quantum number, that represents the shape. So this is shape of orbital, and this represents orientation of the orbital or orientation of the electron cloud. Clear? Yep. So the next one, the energy of an electron in an atomic orbital of a multi-electron atom depends upon principal quantum number only. That is wrong, because we know that we learned in 2 different aspects that when n value is same, it depends upon S like P, then D, then F will come when n values are same, n values same. Correct? Now when L value is same, what will happen, sir? It will be like 1, K, L, M and N. It will be K shell, L shell, M shell and N shell. So I can say the energy, it depends upon both N plus L value. Fundamentally, which is having the highest N plus L value, that will be filled first. Okay, so that's a wrong statement. They are telling it depends only upon principal quantum number. It depends upon principal quantum number and L value. L value is azimuthal quantum number. So my answer here is 3. It's a wrong statement. Now the third one. Tell me, sir, the number of degenerate atomic orbitals. Degenerate means orbitals of same energy. So here we know that s orbital, here entire 3 p orbitals have the same energy. Depends of one type. So p type or d type or s type depends on the values of azimuthal and magnetic quantum number. Correct? Because azimuthal quantum number determines the shape, it is p or not, and the magnetic quantum number determines its orientation. So that's also a correct statement. Clear? So degenerate, so if I am comparing with the P and D, I cannot say that. So of a similar type, of any type, it depends upon what? L value, that gives you the shape, and orientation gives you X, Y or Z. So I can say that's a true statement. So my answer here is 3. Clear? Yeah. So let's move to the next question. I hope you will be able to answer it very properly. Yeah. It's now again a cakewalk. Tell me, which of the following set of quantum numbers belong to the highest energy, they are asking. So we know that energy depends on what? Energy of filling depends upon Aufbau principle, and we know that depends upon what value? N plus L value. So one with the N plus L value, which is the highest N plus L value, that will be, or it will be filled in the increasing order of the energy, I can say. So initially one with lower N value will be, N plus L value will be filled first, then another higher N plus L value, then another high N plus L value. So which is having higher N plus L value here, sir? In the first case you can see 4 plus 0 is coming, 4 plus 0, and that is equal to 4 itself. Here you can see 3 plus 1, okay, that is also equal to 4. Okay, and here also 3 plus 0, that is equal to 3. Okay, and 3 plus 2, here you can see 3 plus 2, that is equal to 5. So this is having the highest N plus L value. So I can say this will be filled first, or it is having not filled first, it will be having the highest energy. Okay, now if you want to see what is the fundamental behind that, it is Aufbau principle. So what is Aufbau principle stating? It gives the sequence with which the orbitals gets filled up. Okay, what is the principle it is stating? The subshell with minimum energy will be filled first. That means the one with the lower N plus L value will be filled first, followed by the next higher value. So if you see here 1s is filling. So 1s means you can say, how you identify this? 1s, how will you expand it? I can say n is equal to 1, and since it is s, L value is equal to 0. So n plus L value here is 1. So 2s means I can say 2 plus 0, here 2. Then 2p means 2 plus 1, here the sum value would become 3. 3 plus s, 3s means 3 plus 0, this will also 3. Now students will have a doubt. Sir, in this case both of them having the same N plus L value. So please remember, whenever there is same N plus L value coming, one with lower N value will be filled first. The one with the lower N value will be filled first. Now 3p means 3 plus p value is 1. So 3 plus 1, 4. Here 4s means 4 plus 0, that is 4. Here also you can see both of them are having the same N plus L value. So one with the lower N value, that is 3, that is filled first. I hope you are understanding. So based on this, we can easily write our electronic configuration of any particular element. Clear? So here I have told it very clearly. So according to the sequence determined with the help of N plus L value, the subshell with the lowest N plus L value will be filled first. When two or more subshell have the same N plus L value, then what happens? The subshell with the lowest value of N, the N or the one with the lowest N value will be filled up first. Now in case of hydrogen atom, there is only one orbital and there is only one s orbital is present. So we consider the remaining orbitals, whether it is 2s, 2s or 2p, 3s, 3p and 3d, 4s, 4p and 4d. All these orbitals 3s, 3p, 3d have the same energy. 4s, 4p, 4d, 4f has the same energy. 2s and 2p has the same energy. Please consider this. This is very important in the case of hydrogen atom. Now the last question for you. The number of angular nodes and radial nodes in a 3s orbital are. So this is very important, calculating the number of nodes. So you need to remember this. Total number of nodes is nothing but n minus 1. Okay, there are two types of nodes. One is called radial nodes. It can be called as spherical nodes or even nodal surface, and this number of radial nodes or number of spherical nodes or number of nodal surface, the value would be equal to n minus L minus 1. And please remember, there is another nodes that is called angular nodes. So angular nodes is also called as nodal planes, and number of angular nodes or nodal planes is equal to L value. Okay. And please understand, nucleus or infinite distance are not considered as node. Very, very important. Okay, this you need to remember. Now, you say, sir, the number of angular nodes and radial nodes for a 3s orbital. So tell me, what is the formula for angular nodes? Just now we have seen. So angular nodes is equal to what value? Just now we have seen. Tell me, sir. Number of angular nodes is equal to what value? L value. L. So here you can see 3s. So s orbital have what L value, sir? S orbital. It is s orbital mentioned. S orbital. So that is having the L value equal to 0. So I can say 0 would be my number of angular nodes. So 0 would be my angular nodes. And what is radial nodes, sir? Radial nodes. So the number of radial nodes is equal to how much? You know that it is n minus L minus 1. You can see here n minus L minus 1. So what is it here? Calculate it. So n value given in this one is, n value is mentioned, that is 3. L value, we know that it's a s orbital, so 0. Then you have minus 1. So 3 minus 1, answer is 2. So considering this, my answer is 0 and 2. So option 1 should be my correct answer. Clear? So I hope you understood. So if you have liked my classes, you can subscribe my channel, and please understand, there are daily, if somebody who is viewing only this video, you can go to my playlist. You can see daily we are discussing 3 questions from every chapter, and we are from Brainiacs Classes, which is one of the best NEET coaching centers in Coimbatore. Okay, so if you would like to watch our tutorials, you can subscribe our YouTube. There the entire chapters with the full description and everything you can see, completely based on NCERT. Okay, problems, everything, free lectures are available. You can prepare, and if you need support offline also, you can contact us. Okay, just search in Google Brainiacs Classes, or you can when you go to the website, you will get WhatsApp contact and everything. Okay, so thank you. So if you have liked our description or the way I have described, you can consider subscribing the channel. Thank you.